This screencast is about taking algebraic expressions and formula and evaluating them using the order of operations. I'm Mr. Pat Dugas. Welcome to your first screencast in Algebra 2. Let's begin our discussion of equations and inequalities by introducing some terms. First of all, the variable is what makes algebra special. A variable gives us the ability to store information. Variables are very useful in math, in programming, lots of different fields. We take a letter, and that letter is used to represent some quantity. Algebraic expressions are combinations of variables and other terms. It's kind of like words in language. And order of operations are where we take an expression and we evaluate it using certain specific rules. Finally, formula are special relationships between algebraic expressions. A famous one would be something like the area of a rectangle is equal to the base times the height. The key concept here is order of operations. And to be able to evaluate expressions and formulas, we need to be able to have some structure, some rules. There's a process that we follow. And the first step is to evaluate anything that's inside a grouping. Could be a parentheses, could be a bracket, any kind of a grouping. We're going to do that first. Having done that, we're going to then evaluate any kind of exponents or powers. Then, crucially, we're going to multiply or divide left to right. Not multiplying first, not dividing first. We're going from left to right with multiplication or division. And finally, the last step in this process is to add or subtract the lowest level of operation from left to right. Some of you have learned this as an acronym, something like please excuse my dear Aunt Sally, where the P is for expressions or parentheses. The E is for exponents, which we're calling powers. The M and D, of course, are multiply and divide, and the A and the S are add and subtract. Remember, though, multiplication and division are done at the same time. Adding and subtracting are also done at the same time. So let's kick this off with an example. We're going to evaluate the algebraic expression x minus y to the quantity to the third power plus 3, given that the variable x is equal to 1 and the variable y is equal to 4. So the first thing we're going to do is go ahead and substitute those numbers in. 1 minus 4 being substituted for the x and the y. And then we're going to do this 1 minus 4 operation inside the grouping, inside the parentheses. And of course, 1 minus 4 gives us the quantity negative 3. Having done the groupings or the parentheses, we then exponentiate. We're going to take negative 3 to the third power, which gives us negative 27 because a negative raised to an odd power is always going to be negative. And finally, once we've done the exponentiation, there's no multiplication or division, so we're going to skip that step, and we're going to add and subtract from left to right. The quantity negative 27 plus 3 is equal to negative 24, and in fact, that is our answer. Okay, let's look at another example here, evaluating an algebraic expression n minus t times n to the second power minus t as a quantity, given that n is equal to 2 in this situation and t is equal to 3.4. Of course, just to chime in, the power of variables is such that we can define them to be anything we want, and so it can change from situation to situation. So we're going to go ahead and do that substitution. Since n equals 2 and t equals 3.4, we can substitute them in. We get this 2 minus 3.4 times the quantity 2 squared minus 3.4. So now we're going to evaluate that grouping, that parentheses. We're going to focus on this part first. And of course, we're going to do the order of operations kind of on its own inside the grouping. 2 to the second power is 4 minus 3.4. So we're doing the exponent next. 4 minus 3.4 is our next step. We're going to subtract 4 minus 3.4, giving us 0.6. So notice, we haven't even worked with this left-hand part. We were always working within those groupings first. So we get 2 minus 3.4 times the quantity 0.6. Gives us, we're going to now multiply and divide from left to right. There's a multiplication here. So we get 2 minus this quantity 3.4 times 0.6, which gives us 2.04. That's where the 2.04 comes from. And so finally, all we've got left is an addition or subtraction. 2 minus 2.04 gives us the quantity negative 0.4, which is, in fact, our answer. Okay, let's take a little bit more complicated example here, evaluating a quotient of two expressions. 8xy plus z to the third power, all divided by the quantity y squared, or y to the second power, plus 5, given that in this situation the variable x stands for 5, y stands for -2, and z is -1. So the first thing we'll do is go ahead and substitute all those numbers in for x, y, and z. Okay, now given that, we're going to deal with the numerator, the top part, and the denominator, the lower part of this fraction, this quotient, separately. Be careful with that. There's really no grouping here, so what we're going to do is we're going to look at any kind of exponentiation or powers. So we've got z to the third power and y to the second power. We're going to take care of those next. So -1 to the third power is -1, and -2 to the second power is 4. So that's where the -1 and the 4 come from. Once we've done that, we can then multiply and divide. Well, there's a multiplication here. The 8xy term is a big multiplication. 8 times 5 times -2. So we're going to evaluate that next now that we've taken out care of the power. So we get 8 times 5 times -2, which is -80, plus -1, all divided by 4 plus 5. Okay, this gives us in the numerator -81, and in the denominator 9. So we get -81 over 9, which is -9. Okay, let's take a look at a geometric example and using a formula. So you may recall from geometry that the formula for a trapezoid, which I've got a picture of a trapezoid up here, a trapezoidal shape, is the area A is equal to 1/2 times the height of the trapezoid times the sum of its two bases. A trapezoidal shape has a long base and a short base. The base of this trapezoid was 13 meters, and its two heights were 25 meters and 8 meters. How do we find the area of the trapezoid? So we're going to use that formula, A equals 1/2 h times the sum of the bases. And now we're going to go ahead and substitute. Since the height is 8, we're going to put in 8 there. Since the bases are 13 and 25 respectively of this trapezoid, we're going to substitute that. So we have basically one grouping here, and that is this part right here. We're going to do our grouping first. Let's look at our order of operations. And indeed, when we add those two terms, we get 38 when we add 13 and 25. So we've done our groupings. There is no powers or exponentiation, but there is one big multiplication. We've got 1/2 times 8, which is 4. All of that times 38. So 4 times 38 is 152. Our answer, the area of this trapezoidal shape, is 152 square meters. So in being able to evaluate expressions and formulas, it's critical that you understand that order of operations. You deal with groupings like parentheses and brackets first, then you exponentiate, then you multiply and divide at the same time from left to right, and add or subtract from left to right. That'll help you to be able to evaluate any kind of expression or formula that you come across. In this screencast, you learned how to take algebraic expressions and evaluate them using the order of operations.